Hello. Today I have the dubious pleasure of explaining the solution to the most missed question on exam 2, Chem 1442. The question reads, at 25 degrees Celsius, the vapor pressure of CHCl3 is 194 torr, and the vapor pressure of CCl4 is 92 torr. Which statement below is the best explanation of this observation? Now, before we tackle this problem, it is imperative that we have a firm understanding of what the definition of four vocab words are. And these words are hydrogen bond, dipole-dipole, dispersion force, and vapor pressure. If you do not understand the definition of these words, I strongly recommend that you revisit these in your book because it will show up on your final exam. Now, to begin, option A says the dispersion force in CHCl3 are stronger than the dipole-dipole force in CCl4. A is wrong because if the dispersion force were stronger, the molecules would not want to separate from the liquid phase, which means the vapor pressure would be less, but that is not the case in this scenario right here because the vapor pressure of CHCl3, which is 194 torr, is actually stronger than the CCl4, which is 92 torr, as depicted by these balloons in these pictures. Another reason why A is not the correct answer is that the dipole-dipole force cannot exist between nonpolar molecules. Option C says the dipole-dipole force in CCl4 are stronger than the dispersion force in CHCl3. Again, this is not correct because CCl4 is nonpolar, which means it can't be a dipole-dipole interaction. Option D, which reads the dipole-dipole force in CHCl3 are stronger than the dispersion force in CCl4. D makes sense in the sense of the definition of dipole-dipole force and the dispersion force, but the statement is wrong when the magnitude of vapor pressure is taken into account. If the dipole-dipole force in CHCl3 was stronger, then the vapor pressure should be less because the molecules would not want to separate from the liquid phase, but that is not the case in this picture, as you can see. E reads, the hydrogen bond in CHCl3 are stronger than the dispersion force in CCl4. There is no hydrogen bond in CHCl3, as you can see from this Lewis structure. Secondly, if there was a hydrogen bond, then the vapor pressure would be less because the molecules would not want to separate, but that is not the case again because the molecules are far more greater in the vapor pressure state in this box compared to this one, and it has a higher vapor pressure. And for there to be a hydrogen bond, where I remember hydrogen bonds are fun, which means it has to have a fluorine, an oxygen, and a nitrogen attached to a hydrogen. Either a fluorine, oxygen, or a nitrogen attached to a fluorine. In this case, there is no fluorine, oxygen, or nitrogen attached to this hydrogen. And secondly, even if this hydrogen were attached to the chlorine, it still would not qualify as a hydrogen bond. B, which reads, the dispersion force in CCl4 are stronger than the dipole-dipole force in CHCl3. B is the correct answer because CCl4, which can have London dispersion force, has a lower vapor pressure compared to CHCl3, which means its molecules will not want to separate. Another way this question could have been phrased is, which one of these two has a higher boiling point? In this case, it would be CCl4 because it has a lower vapor pressure compared to CHCl3, which means more heat is required to disrupt the bonds or the electrostatic bond interactions, not bonds, that's holding these molecules in place.